Hi, everybody, and welcome to Tools of the Trade. This is going to be a companion micro lesson to my website presentation on disabilities in architecture. Today, we're going to be looking into tools used in measuring. On the cover, you will notice a device called a transit. It's on a tripod on the right of that picture. In the middle, there's the target, which the transit basically literally points at and clicks. You're trying to align the target with the lens to get an idea of length. Generally, it does earth coordinates, and it's generally used for alignments in buildings as well as measuring property lines. The third tool you're going to notice on the extreme left is called a plumb bob, and it basically makes sure that the transit is plumb and perpendicular to the Earth's surface. Here's some of the tools of the trade. Above, you're going to see the old style drafting desk that used to be used by many architects. You'll see a parallel edge. Now, in the older style desks, the parallel edge went up and down, but on this one here, it's called a drafting machine, and you see a fixture on there with an angle, and basically that is your triangle. The old parallel edges that go up and down generally used to have you use triangles. So this is actually a much more versatile means of hand drafting. It's sort of become obsolete with the invention of CAD. We're going to be talking next about the architectural scale. The architectural scale is different from a typical ruler. You'll see a ruler-sized measurement on 16, which means basically that's going to be a full scale. Now, that's basically 1 inch equals 1 inch, or 1 to 1. You're going to see a series of numbers on the top part of the scale that go right to left. You're going to see 0 going all the way right to left, and you're going to see numbers increasing going left to right. The numbers increasing going left to right are 3/32 to the foot. Now, the numbers going right to left are 3/16 of an inch to the foot, and to the right of the 0 you're going to see lines. These lines indicate inches. The higher up you go in scale, the more precise it will be, and it will actually become fractions of an inch and then inch marks. The next scale I want to talk to you about is the engineering scale. The engineering scale is very similar to the architectural scale in the sense that instead of doing a fractional measurement, like for instance 1/4 of an inch equals a foot, you're doing things like 1 inch equals 50 feet. Generally, these are used for measuring property lines and basically locations of buildings in relationship to property lines. And so that's generally where these come in handy. And the other issue I wanted to point out too is that for the engineering and the architectural scales, you may be getting drawings that may say that they're written to be 1/4 of an inch to the foot. However, these drawings might not be printed to the same scale. So we're going to talk about this in the next slide. Now, there is an option that you have here. You can scale a drawing electronically. When that happens, basically what this means is you're going to take the actual hard copy drawing, put it on a large format scanner if your firm has one, and you basically take the drawing and you insert it into AutoCAD into what's called a raster image. And you can do a command called reference scaling. Now, what exactly is reference scaling? You're taking 2 points and you're going to say that those 2 points equal that dimension that's listed on the drawing, and that basically will now scale that based on that reference point. So now everything will have a dimension to it. So you can actually measure distances now to get an idea of dimensions for things that are not dimensioned on the drawing. And another thing that you can do with scaling is do something called put it in paper space. And paper space, basically it's like a layout space, like much like a newspaper columnist would use when they're setting up a page on a newspaper. So that's basically what you're doing there, and you can adjust the scale of it, and Usually the scales of the dimensions and the text and everything you use are adjusted for those scales. So you do have to basically follow the standards there. That's where coming to follow standards is very handy when you have to scale something. Another thing you can do is you can trace over an image once the scale is established. However, there's a caveat. These drawings may not be drawn to scale or accurately, so you may actually have a dimension that might not be that dimension. So you have to basically look in either one or more places to figure out if something happens like that. A lot of the older architects used to just change the dimension number if something moved over by, say, like 6 inches. It basically meant that it just changed the dimension number rather than having to redraw the whole item, because you wouldn't really notice the 6 inches in the finished product. So that's something that you might encounter in your experiences as a CAD drafter. In the field, all right, these are some examples of measuring devices we use. Generally, we use the old-fashioned tape measure, which is at the top left picture. Uh, Later practices in firms I've been at, basically I've used the electronic tape measure. This is by far a lot easier to use, a lot less clumsy, and it's great for areas you can't quite get to. For instance, if you have to go to a large volume space and you have to measure the height to the underside of bar joists and you can't exactly get to it, this is where the laser tape comes in handy. Now, the measuring tapes do come in various lengths. You're going to wonder what the one is on the bottom. The one on the bottom is a 100-foot tape measure. This is generally good for measuring large open spaces. Uh, the one above generally can go up to about 35 feet. They range from 24 to 35 feet. And you can definitely make do with these. Now, you can also get a 2 to 300-foot tape measure. This is good for measuring the outside of a building, especially if it's a commercial building. And you could also use a measuring wheel. However, keep in mind with a measuring wheel goes along the ground along the grade, so you're actually getting the length of the travel along the grade and not necessarily the actual length of the structure itself. So that's something to keep in mind.